In this video, I'm going to explain to you how to find the area of the loop formed by the curve y square is equal to x into x minus 3 the whole square. So first of all, what you need to do is you construct the table of this one curve y square is equal to x into x minus 3 the whole square. Then what we notice is that when x is equal to 0, y also will become 0. And when x is equal to 3, then this 3 minus 3 will be 0. So y again will become 0. That means the curve will meet the x-axis at 2 points. One is at 0 and another one is at x is equal to 3. Now when x is equal to 1, then it will be 1 into 1 minus 3. So 1 minus 3 will be minus 2. Minus 2 the whole square will become 4. Y square is equal to 4, which means that y is equal to plus or minus 2. When x is equal to 2, then it will be 2 minus 1 inside. So 2 minus 1 will be minus 1 to the power 2, which will be equal to plus 1 into 2. That means y square will be 2, which means y will be plus or minus square root of 2. And if you see that if you take some more points which are greater than 3, then in that case you'll get two values of y. One is positive, one is negative. But after x greater than 3, after this point x which is greater than 3, then you get two values of y, and then y will keep on increasing to infinity and then to minus infinity. So therefore a loop will be formed only between these 2 points, between 0 and 3. So you note down here that after constructing the table, so we notice that the curve meets the x-axis at 2 points, x is equal to 0 and x is equal to 3. And between these 2 points, there will be two values of y. One is positive and the other is two equal values. Okay, two equal values of y. One is positive and the other is negative. Okay. So a loop will be formed between x is equal to 0 and x is equal to 3. So now you can see from here we need to find the area of this loop between x is equal to 0 and x is equal to 3. We know that from the area of region bounded by the curve y is equal to fx between x is equal to a and x is equal to b, the formula for the area is integral a to b y dx. So here you see that in order to calculate the area of this whole loop, that is the yellow portion and the blue portion here, it's enough for us to calculate only the area of this region that represented by the yellow region and which lies above the x-axis. Why? Because this area here and this area are the same. So it will be 2 times of the area of the region which lies above the x-axis. So now you can write down that one. Since area of the loop OABCO is equal to 2 times of the area OBCO from that graph. So it's enough for us to calculate area OBCO only and then multiply it by 2 and then by 2 to get the required area of the loop. Now, what is this area OBCO? From the graph, this area OBCO is the region bounded by which curve? It is bounded by this curve of the represented by y is equal to square root of x into x minus 3 the whole it will be just x minus 3 only here, because y square is x into x minus 3 the whole square. So on taking y square root, then you get plus or minus, but since this portion here lies above the x-axis, which is positive, so y will be positive square root of x into x minus 3. So you see that this yellow region here is bounded by the curve y is equal to square root of x into x minus 3 between x is equal to 0 and x is equal to 3. So therefore, what will be the required area now? Therefore, area of the loop is equal to 2 times of integral 0 to 3 y dx. But what is y? It is root x into x minus 3 dx. Now, if you multiply this square root of x inside the bracket, then you get x to the power half into x, because root x is same as x to the power half minus 3 into x to the power half dx. And this is equal to 2 times of integral 0 to 3. Then it will be x to the power 3 by 2. You can add the powers of this. It will be half plus 1. Take the LCM. It will be 3 by 2 minus 3x to the power half dx. And this is equal to 2 times of integrals. Let us integrate it now. X power 3 by 2 will give you x power 3 by 2 plus 1 divided by 3 by 2 plus 1 minus 3x to the power half plus 1 divided by half plus 1 from 0 to 3. And this is called 2 times of x to the power 3 by 2 plus 1. And taking the LCM, it will be x to the power 5 by 2. Now in the denominator also, you take the LCM, then it will be 3 plus 2 by 2, which means 5 by 2. So 2 will come to the numerator. So you'll have here 2 by 5 minus. Now here also, if you take the LCM, then you'll get 3 by 2. Now 2 will come to the numerator, then you'll get 2 by 3, then into 3 again here. The power of x will be x power 3 by 2. So from 0 to 3. So this is equal to 2 times of 2 by 5. Then x power 5 by 2 same as square root of x to the power 5 minus, now 3 and 3 can be cancelled. It is 2 times of square root of x cube from 0 to 3. So this is equal to 2 into, now 2 by 5 into square root of 3 cube, 3 to the power 5 minus 2 into 3 to the power 3. Since the lower limit is 0, so we need not calculate it because the value will be 0. So you'll have only this one. So it will be 2 into, now 2 by 5. Now 3 square root of 3 to the power 5. So it will be 9 root 3 you get minus, and it will be 2 into 3 root 3. So this is equal to what? It will be 2 into 9. It will be 18 by 5 root 3. Okay, 2 will be there. So minus, now this will be 6 root 3. Take the LCM, it will be 2 times of 18 root 3 minus 30 root 3, whole thing divided by 5. And this is equal to 2 into 18 root 3 minus 30. It will be minus 12 root 3 by 5, which comes out to be, if you multiply, it will be minus 24 root 3 by 5. But since we know that area is a positive quantity, so therefore we can omit this negative sign. So this will implies that area of the loop is equal to 24 root 3 by 5. be square unit. Okay, square unit. So we omit the negative sign as area is a positive quantity. So hope it is clear now how to find the area of the loop. So first step, what you need to do is you construct a table of this graph. Y square is equal to x and x minus 3 the whole square. So when you construct what you notice is from this given equation of the curve is that when x is 0, the y will be 0. When x is equal to 3, y is 0. So in this type of curve equation will give you a loop, because there will be two values of this curve where it meet the x-axis. Okay, and then when x is greater than 3, then you'll see that it keeps on increasing to infinity, and then downward it will be to minus infinity. And on the left side also, there will be no values of left side of the y-axis. There will be no part of the curve. Why? Because when x is negative, then x will be minus here. Then x minus 3 whole square, this will be positive since it is square, even though if x is negative, but we'll get y square as a negative number. Now, if you take the square root of negative number, it will be imaginary. So that's why the portion of the curve will not lie to the left side of the y-axis, because y will be imaginary there. So there you will have only on the right side of the y-axis, which lies above the x-axis, and the which lies above the x-axis and also below the x-axis. So what you notice is that since the area of this portion which lies above the x-axis is same as the area which lies below the x-axis, so it's enough for us to calculate only the area of this region which lies above the x-axis and multiply it by 2. So on using the formula of the equation of the area bounded by the given curve between x is equal to a and x is equal to b, then you can evaluate the area of this region and then multiply it by 2 in order to get the area of the whole loop. So it will be by the formula from x is equal to a to x is equal to b, y dx. But what is a here? It is 0, and what is b? It is b? It is 3. So substitute it there and substitute the value of y. I'm taking the positive value of y here. Why? Because this portion of the curve lies above the x-axis, so y will be positive, so it will be the positive square root of that y only. And then on calculating this one, finally you'll get the area of the loop will be 24 to 3 by 5. Even though we get it as negative here, then we omit this one because area is a positive quantity.